Hi, I'm Mark Nelson, an architect and developer evangelist. I lead a team that builds, owns, sells, and supports a backend platform that simplifies building and deploying Spring Boot applications and unifies web and mobile development with the power of the Oracle database. Thanks for joining us today. Many developers build microservices and mobile applications, and they need a highly scalable backend to run them on. In this session, we'll talk about an exciting new developer preview from Oracle that provides the ability to run a backend as a service for these applications. This new approach lets developers focus on writing their application, providing simple APIs to access a scalable, reliable, secure backend with all the features modern applications need. Modern apps use containers, Kubernetes, and microservices. We'll discuss the 12 proven patterns for microservices success and how the backend platform brings them together in an integrated stack. The patterns include things like transactions and data consistency across microservices, called sagas, data refactoring, bounded contexts, event mesh, and more. I hope some of you in the audience today use Spring Boot and/or are mobile developers. If so, you'll find the backend simplifies your DevOps and data ops. We have a hands-on lab available here today or anytime online that will guide you through using the backend to build a cloud banking application from scratch. We'd love to hear from you. I'll share our email addresses so you can tell us what you think. There are three key parts to a modern application backend stack: containers, Kubernetes, and of course, the database. There is a separate presentation here at Level Up today about running the Oracle database in containers and the Oracle database operator for Kubernetes that makes the Oracle database Kubernetes native. So I won't cover those topics in depth. If you can't make it to those sessions, don't worry. They will be available on demand after the event is finished. The converged Oracle database is available on cloud, cloud at customer, and on-prem. It's a horizontally scalable, sharded global database that supports all modern data types and workloads, with a transaction manager and event mesh for microservices built in. We'll get into this detail a bit later. A unifying theme here is that the Oracle database is ready for the modern app dev stack that uses Postgres, Kafka, MongoDB, Snowflake as point solutions for operations and analytics. Let's now dive into the backend integration. So let's talk about the backend platform. Backend as a service is an important pattern that is hugely popular in the mobile app dev space, but relatively rare for microservices. It allows developers to focus on the front end or business logic and consume backend services without needing to build or maintain them. It's a perfect fit for cloud and containers, and it allows us to build reliable, scalable, fault-tolerant applications. The Oracle backend for Spring Boot makes it super easy to develop web and mobile apps anywhere with the power of the converged Oracle database. Why do we want a multi-cloud backend platform? Developers' roles are evolving to focus less on DevOps and operations and more on the business logic, and we're developing against higher-level APIs. We're consuming services instead of worrying about configuring infrastructure. The traditional DBAs are becoming more adept with application runtimes and DevOps, and databases are taking on more, with built-in microservices support like event mesh, with both streaming data and batch data for data ops or data engineering. So why Spring Boot? Well, we looked at a lot of data from a wide range of researchers. We looked at things like job advertisements, Stack Overflow questions, GitHub repositories, Google search trends, and so on. And the message that comes through clearly is that Spring Boot and the Spring Framework are by far the most popular, not by a little bit, but orders of magnitude. And we think it's largely because you can write less code, get more done, and there's a huge amount of knowledge and support and a very active community. but we wanted to include mobile developers too. We think that microservices and mobile are better together. Mobile developers tend to rely on backend as a service. Front-end frameworks and tools are quite different to the server side, and mobile developers want to focus on the app. They don't care about boring backend stuff like tables and indexes and what kind of CPU to use. They care about easy-to-use APIs that provide the services their apps need to get the job done. I mentioned earlier that we have observed 12 patterns for microservices success. We all know that most IT projects fail, and microservice projects are no different. By now, it's well established that microservices do not provide a silver bullet. They are not suitable for every project, and they trade one form of complexity for another. But we have also seen enough projects using microservices to be able to identify patterns that lead to success, and we will look at some examples of these patterns in this session. Kubernetes has also emerged as the dominant deployment platform for microservices applications. It provides a lot of capabilities, and of course, it comes with its own complexities. Over the last few years, we've also added a whole host of features to the converged Oracle database to make it the perfect choice for microservices. From pluggable database containers and support for a wide range of data types and workloads, to transactional event queuing and streaming, and features like Saga support. The backend as a service approach is the single most important of the 12 patterns for microservices that separates success from failure. It brings together all the other patterns and realizes them in a scalable deployment that is easy to use and provides a range of platform services for applications to use. Services like authentication, identity, event streaming, monitoring, tracing, deployment, CI/CD, and so on. So let's talk about the Oracle backend for Spring Boot. We have a developer preview available right now on OCI Marketplace. In fact, we have 4 releases already, and we're doing a new release every month. The platform gives you an Oracle Autonomous Database and an OKE cluster, that's Oracle Container Engine for Kubernetes. In that cluster, we pre-install and pre-configure a whole stack of services that Spring Boot applications need. Service registry, config server, workflow, API gateway, Vault, and a transaction manager. We'll talk more about that one later. There's also all the observability tools you need to monitor and manage your applications, identify problems, drill down to find the causes, and trace user requests all the way from their entry at the API gateway through to the database and queuing operations that get performed. We have rich development environment support too, including a CLI and Visual Studio extension, Spring Boot starters for Oracle technologies, and support for all the most popular Spring Boot modules, with more coming in every release. We also provide an on-prem install option today, and we have an Azure option coming very soon. In addition to that, the platform provides mobile app backend services like documents, files, external config, authentication, geolocation and spatial, push notifications, caching, and on-device storage. We have APIs and SDKs across all major popular languages and frameworks, including both the Apple and Android ecosystems, web frameworks like React and Flutter, as well as REST and GraphQL APIs. Of course, all of this is designed to support the 12 patterns. Did you know that Oracle Database has provided application containers for years now? We call them pluggable databases. To the user, it looks like they have a whole database to themselves, but you can run as many of these containers as you like, all on a set of shared infrastructure. Each one is isolated from the others. You can't break out from your container to the host database, and you can easily move these containers from one host to another. Does it sound like anything else you're familiar with? Containers, right? The ones we run our microservices inside of Kubernetes. Spring Boot applications running in containers in Kubernetes, each with its own database container, a perfect implementation of the database per service pattern, or bounded context if you prefer, without the need to manage, maintain, patch, and scale hundreds of individual pieces of database server infrastructure. In fact, we've added a lot of capability to the converged Oracle database over the last few releases, specifically for microservices, and we have even more coming in 23C later this year. Let me highlight just 6 of those. We have direct support for the Saga pattern in the database, transactional event queues and event mesh, including support for the transactional outbox pattern. We have OpenTelemetry and Prometheus collectors for metrics and tracing. We have a tool that will let you analyze actual usage of objects in a monolithic database and help you identify clusters that can be used to refactor that database into bounded contexts. We have Spring Boot starters and SDKs for relational data, streaming, JSON documents, graph, and more coming all the time. And not many people know this, but you can even run microservices directly in the database with instant startup and scale to 0, using popular programming languages like Java and JavaScript. Let's take a moment to talk about transactions. One of the key challenges with microservices architecture in general, and the database per service pattern in particular, is how to handle data consistency. There are lots of ways to do this, of course, and some are more work than others. It really does come down to whether or not a business application can tolerate inconsistency and for how long. For some applications, having inconsistent data for some period is not that big a problem, but for most applications, it's just not an option. Some approaches take developers away from their real work to make sure data is reconciled or forces them to write complex logic to detect and handle issues. A better approach is to use a transaction manager. That's not a new idea. We've been doing that for literally decades now. But today, with the proliferation of microservices, it's just way more important. The backend includes Oracle Transaction Manager for microservices, which enables developers to use distributed transactions to ensure data consistency across services. It supports all 3 of the big models that we see in common use today: XA, long-running actions, and try, confirm, cancel. It has libraries for all popular languages, as well as REST APIs. It's deployed into the Kubernetes right alongside your services, and it works with all common transaction managers, including, of course, the Oracle database and Tuxedo. Let's wrap up this section of the talk. I've told you a bit about how our unified backend for mobile and web apps, plus Kubernetes and the Oracle database, make app dev simple, help you avoid cloud lock-in, and let developers focus on their front ends and business logic. We have a developer preview available today that you can play with, and we'd love to hear your thoughts about it. It's important we know your interests so we can evolve this platform for your needs. We'd love to get more input from customers who are using Spring Boot and would like to get more web and mobile apps convergence. Please consider sending us an email today. Let us know the company you work for, how you use Spring Boot, or your mobile app development approach so we can follow up with you. If you'd like to know more, you can try out the platform right here today in a hands-on lab after lunch. Or if you're watching this later, the very same live lab is available online anytime. In Hands-on Lab 5, you will learn how to deploy the platform, build Spring Boot microservices from scratch, deploy them into the platform, implement the Saga pattern using long-running actions to manage data consistency across microservices, and you will extend the mobile app to add a new Cloud Cache feature that would allow users to send cache to anyone instantly. The lab is based on a Cloud Bank sample application, which is made up of a number of Spring Boot microservices which use the platform services we've talked about today, like the service registry, the API gateway, the transaction manager, and so on. The mobile app is written in Flutter, which is a really exciting new up-and-coming framework for building apps for any screen from a single code base. Just like in a real bank, most of the origination applications, things like opening a new account, applying for a credit card, or buying an insurance policy, are implemented outside of the core transactional banking applications. The cloud cache feature that you will implement touches both worlds. We'd love you to try out everything we've talked about today, and to make that easy for you, we offer free sample code, free trials of Oracle Cloud, a permanent free tier, a free developer version of the Oracle database, and hundreds of hours of free training on our Live Labs platform. Thank you so much for coming today or for streaming this session. As I said, we'd love to hear your thoughts and feedback. Please feel free to reach out to Sanjay or me directly by email. We look forward to hearing from you. Thank you and goodbye.